everyone. This video would focus on multiplying radicals, and this is the first part. Before we go further, please feel free to check out the description box below for the link of the other series of topics related to radical expressions. Before we go over this general rule in multiplying radical expressions, let's have a review on the parts and definition of radical expressions. Please remember that these are the parts of every radical expression. The first part is the radical symbol. The reason why this is called radical expression is because it is an expression that contains the radical symbol. Our a here is called a coefficient. A coefficient is a number multiplied to the radical expression. And the letter n here is called the index. This tells you which root you're looking for. Please remember that if the value of the index is not written in there, it means that that invisible number is 2. We also have a letter C, and this letter C is named as the radicand. A radicand is the value that you are taking the root of. So this expression that we have here is read as A times the nth root of C. So this is read as square root of 36. So if we wanted to know what is the value of square root of 36, we can go ahead and equal this whole expression to x. So this is read as square root of 36 equals x. Now we are going to rewrite this into its equivalent exponential form. This expression or this equation that we have here means that x squared is equal to 36. What is x? So if you notice, our x here becomes the base of the exponential form, while our index of 2, which is invisible, becomes the exponent in the exponential form, and our radicand, which is 36, will become the answer to the exponential expression. What we're trying to do right now is we're supposed to determine the value of x such that when we multiply this x by itself twice, it will give us 36. Meaning if we have blank times blank equals 36, and it should be the same number. So then these two numbers would be 6 times 6. So 6 times 6 is 36. And so we can go ahead and rewrite this as 6 squared equals 36. And so this tells us that our x is 6. So then this square root of 36 then will equal to 6. So that's how we evaluate radical expression. So these are the parts and definition of radical expressions. Okay, going back to the general rule right here, we remember that we can only multiply radical expressions if their indices are the same. If their indices are not the same, then we cannot multiply them. So in this case right here, since both indices here are n, labeled as n, so they're the same, so we can multiply these two together. So what we do when we multiply radical expressions with the same indices would be we multiply their coefficients, that's how we got the AB, and we multiply their radicands, that's how we got XY. Now let's look at some specific illustrations to see how this general rule in multiplying radicals works. Okay, so let's go over this first example. Since both of their indices are the same, which is invisible 2, so that we can go ahead and multiply them together. So their coefficients here would be 1 and 1. It's invisible. So 1 times 1 is 1. And then we multiply their radicands. That would be 8 times 3 is 24. So the answer for this would be 1 square root of 24, and we don't have to write the 1, we don't have to write that index of 2. Now please remember that this square root of 24 can still be reduced to its lowest form. So I'm going to show you the factor tree method in determining or in simplifying this square root of 24. So these are the prime factors of 24. There's another video that talks about how to use the factor tree to determine or to simplify the radical expression. Again, I will put that link in the description box below. So this comes out to be 1, 2, 3. So there's like 3 2's, and there's like 1 3. So we're going to simplify this. Since our index is 2, we're going to pair up 2 of them. So this comes out to be, that's the square root of combining both of them. So that would be square root of 4 times square root of 6. And so we go ahead and say square root of 4 times square root of 6. And so this comes out, square root of 4 is 2, and then square root of 6 is just square root of 6. So then our final answer here would be 2 square root of 6. Now let's move on to the next example. In this example, we're supposed to multiply 3 square root of 7 times, the parentheses tells us that it's multiplication, negative 5 square root of 8. So we have to look at their indices, and their indices are the same. It's invisible too because it's square root. So then we can go ahead and multiply them together. So what we do when we multiply again is that we are supposed to multiply their coefficients. So that would be 5 times negative 3 is negative 15. And then we also multiply, we write the square root and we multiply whatever's inside this radical symbol, which is the radicand. So that would be 7 times 8 is 56. So that we can go ahead and simplify this further, that would be negative 15. This 56 can be broken down into its factors such that one of the factors is a perfect square. So that would be 4 times 14. So 4 times 14 is 56. And so we can go ahead and say that would be negative 15 square root of 4 times square root of 14. And square root of 4 is 2. So that's negative 15 times 2 times square root of 14. And so the final answer for this would be, we combine those constants. So we have negative 15 times 2 is negative 30 square root of 14. So this is the simplified version, or this is the product between these two radical expressions up there. Now let's move on to the next example. Okay, in this example, we have one term outside the parentheses and we also have two terms inside the parentheses. So that means we are going to use the distributive property for this. So we are going to distribute this 2 square root of 5 to each of the terms inside the parentheses. So we're going to start by multiplying these two, and then I'm going to write it out here. So that would be 2 square root of 5 was multiplied to the first term inside the parentheses. So that is times 7. And then plus, we are going to distribute this 2 square root of 5 as well to the other term. So that would be 2 square root of 5. And then that is multiplied by negative 3 square root of 15. So then we go ahead and simplify this. So we're going to multiply them. So these two shall be multiplied together. 2 times 7 is 14. Now others are going to say, like, why is it that we're not multiplying 5 and 7? Remember, 5 is a radicand and 7 is not a radicand. So we cannot multiply them together. So that would be 2 times 7 is 14. Then we keep the square root of 5. And then we have here plus, and then we put in these two together. So this one right here would be 2 times both coefficients. So 2 times negative 3 is negative 6. And then we have a square root of, that's going to be 5 times 15 is 75. So then we go ahead and simplify this further. We can go ahead and rewrite this as 14 square root of 5 minus 6 square root of 75. So this square root of 75 can still be simplified further. We can go ahead and say that that is actually 6 square root of, the perfect square that goes with 75 is 25, and that's going to be 3. So that's the perfect square, and we got a 3. And so we go ahead and rewrite this as 14 square root of 5 minus 6 times square root of 25 times square root of 3. And so 14 square root of 5 minus 6 times 5 square root of 3. So then we go ahead and multiply these two together. So that's 14 square root of 5 minus 30 square root of 3. Now notice that these two cannot be simplified further because although their indices are the same, but their radicands are not. So we go ahead and say that this is the product of this expression that we have up there. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So we're going to use the distributive property for this. So this square root of 5 will be distributed to each of the terms inside the parentheses. And I'm going to show the work on the side up here. So what I did here was that I multiplied, remember there's an invisible 1 in front of the 5. So that would be 1 times negative 2 is negative 2. 5 times 3 is 15. And we also have 1 times 1 is 1. And then 5 times 5 is 25. And so when we simplified it, it's going to be 5 minus 2 squared of 15. Did you get the same answer as this? Good. Perfect. Now let's move on to the next example. Okay, so we're going to go over the problem here. So we have here this one term on the left side of the expression, and we have two terms inside the parentheses. Again, we are going to distribute this outside term into each of the terms inside the parentheses, and this is how it's going to look like. So I'm going to multiply this negative 2 squared of 15 and negative 3 squared of 3. So what I did was I distributed it. I multiplied these two together. That's how I got this. And I multiplied these two together. That's how I got this. Now we are going to multiply these terms here. So we go ahead and say that's negative 2 times negative 3 is a positive 6. And then we have square root of 45 because that's 15 times 3 is 45. By the way, we can do this because both of their indices are the same. So then we go ahead and do the rest of the other part here. So that's a plus. So these two would be negative 2 times 3 is negative 6, and that would be a square root of 15 times 5 is 75. So then we simplify this further. This is 6 square root of 45 minus 6 square root of 75. So we can simplify this 45 and this 75. So that would be 6 square root of, the perfect square that goes with 45 is 9. So that's 9 times 5 minus 6. The perfect square that goes with 75 is 25 times 3. So then we can go ahead and rewrite this as okay, so the product of this expression that we have right here is 18 squared root of 5 minus 30 squared root of 3. The reason why we cannot simplify this further is because the radicands are not the same. We have a 5 and we have a 3. So this is already the final answer. Now let's move on to the next example. In the previous examples, we had square roots. The same rule works for cube root as well. So in this case right here, we have a distributive property still because we have one term outside the parentheses and two terms inside the parentheses. So we can go ahead and multiply these two together. So I'm going to write it out here. So that would be 2 cube root of 16. And then that is times negative 4 cube root of 2, and then that's a plus. Then we distribute this one again to the other term. So this would come out 2, and then cube root of 16, and then that's gonna be times 7 cube root of 54. So what are we going to do next is we'll look at their indices. Both of their indices are the same. So we go ahead and multiply their coefficients and multiply their radicands. And the same thing for this, they have the same indices, so we're going to multiply their coefficients and multiply their radicands. So this side of the equation would look like this. Okay, so what we do now is we are going to factor this 32 and this 864 in such a way that one of the factors is a perfect cube, because this is a cube root. So this would come out negative 8. The factors of 32 with a perfect cube in it is 8 and 4. So that would be 8 times 4. 8 is a perfect cube, and 8 times 4 is 32. And so we go ahead and do the same thing for 864. So that's 14. Factors of 864 with a perfect cube is 216 times 4. So 216, the cube root of 216, it's a perfect cube. And then we also have 216 times 4 is 864. So we can go ahead and simplify this further. This would come out negative 8 cube root of 8 times cube root of 4. And then we have 14 cube root of 216 times cube root of 4. So that we can simplify this further, that is negative 8. Cube root of 8 is 2. And then we have a cube root of 4. And then we have 14. The cube root of 216 is 6. And then we have a cube root of 4. So then we go ahead and simplify this further. Negative 8 times 2 is negative 16. Cube root of 4. And then that's a plus 14 times 6 is 84. Cube root of 4. Now if you notice, these two expressions have the same indices here, and they have the same radicands. So we can go ahead and simplify them. And so the final answer for this would be 68 cube root of 4. So this is the product of this expression that we have up there. That's it. If you found this video helpful, hit like and subscribe for more math videos. See ya!